Hello everybody. Good morning, good afternoon, or good evening wherever you may be. Welcome to today's webinar called What's New with AWS, and we will be looking at the introduction to cloud computing with AWS today. My name is Markku Lepistö. I'm a technology evangelist for AWS working out of Singapore. So in this webinar, we will have an introduction to cloud computing. It's 101 level. This webinar is aimed at audiences who are new to these topics. First, let's take a look at some housekeeping. The presentation itself will be running roughly 45 minutes. During the presentation, you can post questions online, and we will be answering some of them with the help of our solution architects. And at the end of the webinar, we also have a Q&A, questions and answers. And a reminder, please fill in the survey. We love customer feedback, and your feedback lets us know how we can improve our services. So let's take a look at today's agenda. First, we will take a look at AWS in general, as a general introduction. Next, we will take a look at the benefits of using AWS and cloud computing. Then we will take a little bit closer look at the AWS services that we provide, followed by typical use cases. And finally, we look at some common strategies how companies are getting started with AWS. So let's get going. We'll start with the introduction to AWS. Here in this slide, you see a simple view of the set of services offered by AWS. At the core of the offering are the compute, storage, and data services. Those are the primary building blocks on top of which everything else is built. We then surround these offerings with a range of support components like management tools, networking services, and application services, such as lifecycle management and monitoring. All these capabilities are hosted within our global data center footprint that allows you to consume the services without having to build out your own facilities or procure hardware equipment to do so. And this view shows the number of new services and features we have launched since AWS was started. In 2010, we launched 61 significant services and features. In 2012, it was 159. And last year alone, we have launched 280 services and features. So the pace of innovation at AWS is accelerating. In this picture, you see the AWS data center footprint. It's global. It's spanning 5 continents with highly redundant clusters of data centers in each of the regions. Our footprint is expanding continuously as we increase capacity, redundancy, and we add locations to meet the needs of our customers around the world. And in this picture, you can see the latest region that we announced recently, the China region. AWS is solving problems for big organizations across many verticals and geographies. We are quite proud of our customer list, and we are happy to know that we are providing good outcomes and better results for some of the best companies in the world. In the public sector space, over 600 governmental agencies and 2,400 educational institutions worldwide use the AWS services. These range from the NASA JPL Jet Propulsion Laboratory to the city of Melbourne in Australia and many others. But we as AWS could not do this alone. That's why we have an extensive partner ecosystem. Our partners are providing exceptional customer service and helping a large number of customers run their applications on AWS. Recently, we have announced 22 consulting partners as the 2014 Premier Partners. In addition to the global companies, some of which you see on this slide, we have a large number of local partners serving customers in the Asia-Pacific region. Now, Let's move on to the benefits of cloud computing and using AWS. The first one being security. Now, security is the #1 priority for us at AWS. You might have questions about security in the cloud, but our biggest and most conservative customers have found that we are able to meet their security requirements, and often we can actually provide a better security profile than what they can deliver internally. The AWS Cloud Infrastructure has been designed and managed in alignment with regulations, standards, and best practices, including HIPAA for medical and ISO 27001. Recently, we announced a service called AWS Cloud Trail. It enables you to record API calls made on your account, so all the activities that happen against your account at AWS. And Cloud Trail then delivers log files to your Amazon S3 storage bucket. Cloud Trail provides increased visibility into AWS user activity that occurs within your account and allows you to track changes that were made to your AWS resources. This allows enterprises to run comprehensive security analysis and better manage their governance and compliance efforts. Cost. Cost is quite typically, if not the first, then the second conversation topic when talking about cloud computing. There are many pieces to cost conversations when it comes to AWS and when it comes to your own infrastructure on premises. The first advantage that you get in the cloud is that you don't have to lay out capital expenses for hardware and infrastructure before you know the demand. So you can avoid upfront capital investments. In essence, you can convert your capital expenses into variable costs, variable expenses. And that variable expense on AWS is lower than most companies can do on their own, because AWS runs at massive scale, and we pass that scale to our customers in the form of lower pricing. Until now, we have lowered our pricing 40 times. In addition to that, there are multiple pricing models in AWS, so you can optimize your spend depending on what your workload requirements are. And the more you use AWS, the less your costs are. We have tiered pricing, and for customers doing large data center migrations, we have negotiated custom pricing to make their transitions cost-effective. Let's take a closer look at the many purchasing options that support your different needs for procuring IT. On the left, we start with the free tier. Free tier is a really nice way to get started on AWS with completely free usage and no commitments. It's really nice for doing initial evaluations of many of the AWS services. The second one is on demand. This is when you pay for compute capacity by the hour with no long-term commitments. This is ideal for development and testing scenarios and, for example, peaky workloads. Moving on, then we have the so-called reserved instances. With reserved instances, you make a low one-time payment and you receive a significant discount on the hourly charges. Reserved instances are ideal for baseline workloads. So basically, if you know that you will be running services or systems in the cloud for a longer period, you can then achieve large cost savings by using reserved instances for those instances like databases that you're running maybe 24/7. The next one is Spot. Now this is really interesting. Spot instances let you bid for unused capacity in the AWS data centers. This capacity is charged at a spot price, which is fluctuating based on supply and demand. So it's kind of like a marketplace, a stock marketplace for unused capacity in the cloud. You can achieve tremendous discounts and cost savings compared to on-demand by using the spot Oftentimes the spot price may be lower than the on-demand price, but occasionally it might actually be higher because it is fluctuating based on supply and demand. Spot prices and spot instances are really ideal for test scenarios and, for example, large-scale simulations. Then we have dedicated instances. Dedicated instances mean that you can launch Amazon EC2 virtual machines or instances within VPC, our virtual private cloud offering, that runs on hardware dedicated to a single customer or single tenant. In other words, by using dedicated instances, no other tenants' instances are running on the same piece of hardware. This is mainly used for highly sensitive or compliance-related workloads. Over the years, we have learned, and our customers with us have learned, the many benefits of cloud computing. And we've come to the conclusion that in many cases, increased business agility is actually the #1 reason customers and businesses use AWS and the #1 benefit. Now, what is that? Nowadays, companies cannot afford to be slow, or their competition will overtake them. In the old world, using legacy enterprise IT, it would take weeks, even months, to procure new systems and to set them up and put them into production. Now, using AWS, you can deploy infrastructure and useful services in a matter of minutes. For example, you can add a new development and testing environment or new production environment to increase your capacity, deploy your services to Japan or South America. You can easily add 1,000 servers or remove those 1,000 servers when the test is over or when you don't need this capacity anymore. So you can think of it as disposable on-demand infrastructure. You can do the same for many of the other services. For example, you can deploy data warehouses and shut them down when you don't need them anymore, and then you also stop paying for them. Now, this is a huge difference compared to the old world. Everything changes with this kind of agility. What this actually enables companies to do is to unleash innovation. In the old world, when you had to procure upfront CapEx hardware and it was costly, time-intensive to actually set it up, the cost of failure was high. You had to imagine whether your new service will be successful or not. It's hard to predict that. And because the cost of failure was high due to the associated time and capital expenses, then companies became risk-averse. And then that had a negative impact on innovation and experimentation. Now with the cloud, the cost of failure is approaching zero. This allows companies to experiment often, fail fast and quick at low cost, and experiment, and through experimentation, you unleash innovation. And those services that work, those new ideas that work, are tested in production. You can then scale out to meet the capacity demands. Next, let's take a slightly deeper look at the AWS services portfolio. In this slide, you can basically see a map of our different services. Now, I'm not going to talk through all of these, or we would spend the next hours in this one slide. But let me try to explain in general what we are looking at here. If we go from the bottom up, on the bottom you can see our global infrastructure. Those are our regional data centers and availability zones. The availability zones are clusters of data centers within the same region, interconnected by low latency networking. So using our regions and availability zones, you can deploy your services, your applications, store your data in the regions of your choosing. And you can distribute your applications and data across multiple data centers for fault isolation. We have also our edge location, providing our content delivery network CloudFront and Route 53 DNS services. So on the bottom, you have our global infrastructure. And then the global infrastructure is providing services such as the foundation services. Those include the compute, storage and networking offerings, databases, big data analytics, and the content delivery network that I mentioned. Now, the funny thing is that AWS is built on AWS. So you can think of these as Lego blocks, and these are the foundation services are the foundation primitives upon which everything else is built. So on the next tier, we have the application services, such as simple email service, notifications, message queues, video transcoding, search engines, workflows, etc. And on top of those, we have application deployment and management, lifecycle management services such as monitoring, application deployment, infrastructure as code services, which I will talk about more later, identity and access management, etc. So AWS is built on AWS. On the right, you can see the ways you can interact with the AWS services. You can see that there's one block called API. All the services that we provide are accessible through application programming interfaces. So AWS is in effect a set of programmable data centers and programmable services. You can interact with the services using our web console, using the command line, or directly from your programming language from your applications using our libraries and SDKs. And no matter how you interact with the AWS services, it's always using the APIs to actually talk to the cloud. Now let's take a closer look at some of these. First, let's take a look at the compute services. So Amazon EC2, or Elastic Compute Cloud, provides elastic virtual servers in the cloud. You can run any operating system you want there, typically Windows, Linux, or even BSD Unix on x86. We have different sizes of instances that provide different amounts of virtual hardware. We have compute optimized, we have storage optimized, we have small ones, we have very large ones, we have instances which even have general purpose GPU, floating point cards installed, etc., etc. So we have a large portfolio of instance types that you can choose from to suit your application and workload requirements the best. And once you have identified what size or what type of instance suits you best, then you should scale out by just simply provisioning more of those instances to meet the capacity demands. That's where autoscaling helps. By leveraging autoscaling, you can automate provisioning more instances when your customer demand increases, when you have more traffic, and crucially, when the traffic goes away at night time, maybe during the weekend, you can release resources that you don't need and you stop paying for those, so you pay less. Using autoscaling, you can achieve the variable low costs using the cloud. Compare this to the old world of IT, where you had to make upfront CapEx investments, you had to make capacity planning, or how I like to say capacity guessing, and then you had static capacity, which often was either too much or too little capacity. With the cloud, you can right size your environments to meet your actual demand. Typically paired with the autoscaling, customers like to use our Elastic Load Balancing service. The ELB, or Elastic Load Balancing, provides an endpoint where your customers can send the traffic. Elastic Load Balancing is then monitoring a pool of servers. These are easy to instances running your application stack, for example, web servers or application servers. And the Elastic Load Balancing will balance the traffic equally across these multiple servers. And autoscaling is then responsible for growing or shrinking the size of the server pool to meet the actual customer demand. Now, let's move on to networking services. Let's start with the Amazon VPC, or Virtual Private Cloud. Using VPC, you can get secure, private, and isolated sections of the AWS cloud carved out just for you. And you can connect to the VPC with VPN connectivity. AWS Direct Connect provides you with private connectivity between AWS and your data center. So in practice, you can provision your own cables that you run to peering points that are connected to the AWS data center. You can, for example, provision 1 gigabit or 10 gigabit links. And the recommendation then is to use multiple links for redundancy. Amazon Route 53 is a global domain name service. So with Amazon Route 53, you can easily host your root domains and manage your subdomains in the cloud. Moving on, let's move to the storage services next. We start on the left with the Amazon EBS, Elastic Block Store. They are volumes whose life cycle is separate from the EC2 instances. EC2 instances are the servers, and if your servers require more block storage volumes that are attached to the servers, you can provision EBS volumes. And you can attach them and you can detach them from EC2 instances. You can provision multiple volumes and you can attach multiple volumes to EC2 instances. We have also a feature there called PIOPS, provisioned IOPS, that gives you deterministic provisioned I/O throughput and performance to these storage volumes. Amazon S3 is our object store that we call the storage for the internet. So Amazon S3 is an internet-scale storage accessible through APIs. It's highly durable with 11 nines of durability, and it has unlimited capacity. So with S3, you don't need to do storage capacity planning anymore. S3 is also able to serve content, static content, directly from the storage over HTTP. So in some cases, you don't need web servers necessarily. You can have your static contents served to your customers directly through S3. Then next to S3, we have a complementary service called Amazon Glacier. Glacier is a deep archiving service. It's used for archiving and backups. Glacier provides the same 11 nines of durability as Amazon S3 at a significantly lower cost. To move your data and content to the cloud, you can run a virtual appliance called AWS Storage Gateway in your on-premises system, data center, or office. So using AWS Storage, backed up to the cloud, either in Amazon S3 or Glacier. You can also easily do lifecycle management operations where data expires from S3 based on rules that you set. For example, when these files are more than 1 month old, move them automatically to Glacier and reduce my storage costs. Next, let's move to databases. Databases are required for most applications. However, it's not easy to run, to configure, to deploy, to keep secure, to back up, maybe replicate your databases. Databases are complicated, everybody needs them, but they can be really difficult to maintain and operate. That's why we provide fully managed database services that can make your life easier. Starting on the left, we have Amazon RDS, or Relational Database Service. This is a fully managed service where you can choose the engine, for example, Oracle, Microsoft SQL Server, MySQL, or our latest addition, the PostgreSQL database engine. With RDS, you simply choose the engine, the size of your database, and then deploy it. And RDS can make your database highly available across multiple availability zones or clusters of data centers. You can have automated backups, automated minor version upgrades, and even replications across regions. Complementing the SQL database service, we have the Amazon DynamoDB. Amazon DynamoDB is a fully managed, or we call it zero management, no SQL database service. DynamoDB provides provisioned throughput at any scale with less than 10 milliseconds request latency. Many companies these days actually use a combination of SQL databases, for example with RDS for the complicated queries, and then the very hot tables they can locate in DynamoDB with the provisioned throughput. Another way of increasing SQL database performance is to offload some of the database requests with a caching service. Here we have Amazon ElastiCache, which is an in-memory caching service, providing you with either Redis or Memcached compatible caching services. So it's really handy to deploy ElastiCache in front of your RDS databases and then point your read request to the cache first. In many cases, you can offload a lot of the traffic away from your master database to the caching service, which is in memory, so it's extremely fast. Moving on, more about data services. Here we have some of the AWS big data services. Nowadays, Hadoop, the friendly yellow little elephant, has become really the de facto toolkit in the middle of the big data analytics for offline data analysis. So Hadoop provides a couple of things. It has the HDFS, reliable storage, and an implementation of the MapReduce parallel processing algorithm. Hadoop is really handy for crunching large numbers of data because it can distribute the job across many hundreds, even thousands of worker nodes which are running on EC2 virtual machines or instances. That's all good, but installing, configuring Hadoop is not easy. Maintaining a Hadoop cluster is not easy. That's why we have packaged Hadoop in a fully managed service in the cloud. We call it Amazon Elastic MapReduce. It provides Hadoop as well as easy integration to many of the complementary big data services like Hive, Big, DataSpace, etc. that you generally use to interact with Hadoop and to make your big data solutions better. In the middle, we have the AWS Data Pipeline. That is a service that can help you move your data between AWS services and even on-premise data sources. On the right, we can see Amazon Redshift. Redshift is a petabyte-scale data warehouse service. It has a couple of interesting features. First of all, it costs roughly 1/10 of traditional data warehouses. Secondly, it's fully managed. And leveraging Redshift, you get all the benefits of cloud computing, including on-demand, low variable costs, etc. Now, let's talk more about application services, application level. We mentioned CloudFront earlier. With Amazon CloudFront, you're able to distribute your content globally. So let's imagine a scenario. You're running your servers, for example, here in the Asia Pacific region, for example, out of the AWS Singapore data centers, but some of your customers may be in North America or Europe or South America. Using CloudFront, you can significantly improve the customer experience for your end customers. You can achieve this by adding a CloudFront distribution in front of your services and your content. You can now put CloudFront in front of your whole entire website. CloudFront will then cache the frequently accessed content locally in the regions and countries near your end customers. We have currently 51 edge locations, and we are constantly expanding those. So for example, in Europe, your end customers will get the content from a local cache which is in the same country or likely in the nearby country of your customers. Then, search engines. Many web services, many products today manage a lot of data. You need to find that data, maybe internally, and especially you want your end customers to discover your products, to discover your offerings. So you need a search engine for that. Building and managing a search engine is not trivial. That's why we have made the Amazon Cloud Search service, which is a fully managed search engine service. You can easily point your data to the Amazon Cloud Search and have it available through easy-to-integrate search engine capabilities. Then we have the Amazon Elastic Transcoder, which is significantly simplifying video transcoding in the cloud from your source mezzanine files into different formats. Moving on, let's talk about deployment and administration tools. Ultimately, you will need to deploy your applications. You will want to leverage services like RDS to have databases, maybe the search engine, maybe CloudFront, Route 53. But at the essence of your offering is probably your own code, your application. You need to be sure that your application is healthy, it's scaling to meet the customer demands. You need to identify any problems. You want to upgrade your code in production. And you need to manage the life cycle of your application in general. Here we have a set of services, including on the left, Amazon CloudWatch, which lets you monitor the resource utilization of the resources and components that build your service. You can have CloudWatch monitor, for example, your EC2 instances, and even your custom metrics provided by your application. You can integrate those to CloudWatch. Next, AWS IAM, Identity and Access Management. This gives you granular management of your users, your user groups, and individual permissions to different services and different resources running in the cloud. So basically with IAM, you can, for example, have your development teams, your testing teams, your operations teams having different access to different parts of your system with different privileges. AWS OpsWorks in the middle is a management system that supports the DevOps ideology. With AWS OpsWorks, you can easily deploy stacks of applications into production. You can do rolling upgrades. It supports integration with continuous integration and continuous deployment frameworks and tools. With AWS CloudFormation, you can basically templatize your entire service or application in the cloud. So with AWS CloudFormation, you can describe your entire deployment from your code to all the services that your application leverages, like the databases, the DNS services, etc., as a piece of code. And this code is actually text, and this text file, which is the CloudFormation template, you can store in your version control system. This brings interesting benefits. With AWS CloudFormation, you can store the description of the infrastructure required to run your application alongside the code of your application in the same version control system. Then you can easily deploy the current version, or for example, the version of your application 2 versions back, which maybe had a different database. You just deploy the template into production, and CloudFormation builds this system according to the template then. We often call this infrastructure as code. Finally, we have the AWS Elastic Beanstalk. The point of AWS Elastic Beanstalk is to make it really easy for you to just simply focus on coding. With Beanstalk, you can just deploy your application and ask the Beanstalk service to kindly run it in the cloud for you. And then Beanstalk will take care of all of the infrastructure, building, configuring, etc., to run your application in the cloud, either as a single instance to save cost or as a load-balanced, highly available environment in production. So with Beanstalk, you just focus on application development and you run your app in the cloud. Now, let's move to typical use cases. How is AWS often used? We have a couple of scenarios here. The first one are web, mobile, and social apps. So on the top of the picture here, you see a simple, pretty typical deployment scenario or architecture. On the left there, we have Amazon Route 53. You need to host your domain name somewhere, www.mygame.com. Amazon Route 53 can host this domain name for you and provide the DNS service out of the global Amazon DNS servers. And you can easily manage changing and adding these domain names and root domains with Route 53. Next, you need to provide content to your customers. For example, your images, your video files, your CSS files, your JavaScript, etc. That's where Amazon CloudFront, the content delivery network, can really help speed up and improve the content download, making the latency and bandwidth better for your frequently accessed content. CloudFront is also able to offload many of the requests so that you don't need to run so much infrastructure in the backend. CloudFront typically fetches the content from Amazon S3 for static content, but it can also fetch content from dynamic applications running on EC2. So when we start moving towards the dynamic applications, the next service here is the Elastic Load Balancer. So Elastic Load Balancer provides a service endpoint behind which you have a dynamic pool of EC2 virtual machine instances providing your application. In this application, we actually have a couple of application tiers. So maybe first a web server tier with a public-facing ELB, and then maybe an internal load balancer with some application servers in the back. And they also have an auto-scaling group here so that they can meet the capacity demands, whatever they may be. Finally, at the backend, then you need typically databases. In this example, we have a master and a standby SQL database provided by Amazon RDS. Those could be MySQL or Postgre, for example. Then finally, at reInvent last year, we introduced Amazon AppStream, which is a new flexible interactive application streaming service. So the idea is that you can tap into the massive compute and rendering capacity in the cloud and then efficiently stream the user experience across multiple devices. So your users are interacting with the service application sends back the user input back to the cloud, and then the game, for example, is rendered in the massive capacity of the cloud. It's Amazon AppStream. When we talk about big data, we have to think about the actual business needs. So the point of big data is that you want data to steer your business decisions. You want to have actionable insights. Basically, you don't want to guess your roadmap. Your customers who are using your service, they are basically telling you through their interaction with your service how much they like the service. So examples here include, for example, web server click logs. Maybe you do A/B testing to see if this feature or that feature or this color of this button works better. Which ones do my customers like more? All of this information you should collect in log files. The log files contain all the interactions of your customer with your service. If you have a global service, the number of log files and the number of interactions can be quite massive. That's the big in big data. And you also want to react to these insights as quickly as possible so that you're an agile business. So you may have massive volumes of data coming in or being generated, and you want to act on this quickly. That's where you need big data services that can scale out to these capacity demands. AWS provides a portfolio of services that can make your life easier to build these big data pipelines. On the left, we have the Direct Connect, where if you regularly need to transfer a lot of data from your on-premises system to the cloud or back, you can use Direct Connect and you can have your own dedicated 1 gig or 10 gig links or even multiples of those. If you need to simply upload, if you will, a very large amount of content into the cloud, we have the service called Import-Export. Some people call this the sneaker net. In this, basically, you ship your hard drives to AWS, and then the hard drives are received and the content is loaded into S3. And you can do it the other way around to send massive amounts of data with hard drives shipped back to your offices. This is, if we have a technical joke here, it's slightly bad latency, but it's extremely high bandwidth. Next is the storage services. Amazon S3, unlimited capacity, 11 nines of durability object store, typically this is where many companies keep their master data. DynamoDB, our extremely fast NoSQL service, and Glacier, the deep archiving service. Then we have analytics services, Elastic MapReduce, Hadoop in the cloud. With EC2 instances, you can run any software that you need if you want to build it or configure it yourself. Redshift is the data warehouse, and you can easily have, for example, EMR, Hadoop jobs, MapReduce jobs, clean up your data, and then upload them to the columnar Redshift data warehouse database for then business intelligence analytics. And finally, at reInvent, we introduced Amazon Kinesis, which is our exciting new fully managed service for real-time processing of streaming data at any scale. When we talk about enterprise applications, naturally you will want to continue using some of these business-critical applications in the cloud as well. AWS offers a reliable and secure cloud infrastructure platform that enables enterprises to quickly launch entire enterprise software stacks from Oracle, SAP, and Microsoft, and many others in the cloud. Customers using Oracle, SAP, and Microsoft products can also use the existing software licenses on AWS without any additional license fees. Finally, RDS gives you access to the capabilities of familiar MySQL, Oracle, Microsoft SQL Server, or PostgreSQL database engine as a managed service. Moving on to a different scenario, disaster recovery. If you're running your production systems out of your own on-premises system, your own data center, you will still want to have a disaster recovery plan. You need to have a secondary site, but building out a secondary site, which typically has to be a replica of your primary site, can be very expensive. And interestingly, you don't really use it unless you have a big disaster in your primary site. So the legacy way of building disaster recovery sites is very expensive, especially capital upfront expenditure. Nowadays, businesses are using the AWS cloud to enable faster disaster recovery of their critical IT systems without the capital expenditure of a second site. The AWS cloud supports many of the popular disaster recovery architectures, including Pilot Light. With Pilot Light, the idea is that you are replicating, for example, with asynchronous mirroring, your primary databases to the cloud. And your production systems can be hibernated in the cloud. And only if you need to fail or if you have a disaster in your primary site, you already have a copy of your master database up to date in the cloud. And then you will simply bring up the hibernated instances and resources that are your application, etc. servers. And using Amazon Route 53, you can then manage migrating your IP traffic over to the copy in AWS Cloud. To complement this, we recently launched the cross-region read replica feature in RDS that you can use to implement a disaster recovery model where your existing database is copied or replicated to a new global region. This is also a handy way to replicate your service to another geographical region, copying your master database content to another geographical place. Now, let's take a look at some of the common strategies how companies are getting started with AWS. In strategy number 1, the cloud is used for development and testing. Here we have a couple of customer examples. For example, Lionsgate is running SAP development and testing environments. The Tokyo Stock Exchange is testing Oracle apps on AWS, and Galata Chemicals are testing SAP deployments on AWS, and they have reported a 70% reduction in operational costs. Development and testing is quite often the first step into trying cloud computing in AWS. The second step involves what some people call the systems of engagement, or net new applications built natively in the cloud and for the cloud. These new workloads are really no-brainers to be cloud native from the get-go. There is no legacy package with them that you would have to migrate from. Cloud native applications can be cheaper and less expensive, easier to build, faster to deploy, more automated, and they can easily leverage the fault-tolerant capabilities of the cloud and then enable massive scalability through scale-out design. You can see this, for example, with customers like PBS, who run a video streaming service on AWS, and Qantas Airlines, who has built their hotel booking application on AWS. Strategy number 3. Using the cloud to make your on-premises applications better. We have started seeing more and more of these during the last 12 months. This strategy is about taking applications on-premise and complementing them with the cloud resources. You can see this especially in the analytics and batch processing area. So the idea is that you can have big data analytics, business intelligence, for example, by uploading the log files, necessary log files from your on-premises system to the cloud using, for example, Elastic MapReduce to run Hadoop jobs, maybe using Redshift for analytics, Amazon S3 for storage of this content, and then bring back the results to your business decision makers. So with this way, you can enable big data analytics and actionable insights without having to invest heavy capex in building a large Hadoop cluster or data warehouse in your dataset. Here we have a couple of customer examples. NASDAQ has quite a number of market operation applications. NASDAQ analyzes this data in the AWS cloud during the night time and then move it back to their on-premises applications during the daytime for their users to leverage. And Nokia had a data warehouse on-premises. It was hard to manage and could be fragile. Nowadays, Nokia run their data warehouse on AWS, where the queries nowadays run twice as fast and at half the cost of their legacy system earlier. Strategy number 4, cloud applications that integrate with on-premises systems, hybrid applications. This strategy is the reverse of the previous one. Here, the applications that are natively built on the AWS cloud reach back to your on-premises resources. The example here is Samsung and their Smart Hub applications. Samsung built out their Smart Hub service on the AWS cloud, but they needed the financial transactions to happen on their on-premises systems. So when the customers buy some content from Samsung, they transition to the on-premises system for the financial transaction and then transition back to the AWS cloud seamlessly for using and delivering the content. So this is an example of a real-life production hybrid application system. Strategy number 5, migrating existing applications to the cloud. This one requires a little bit more thinking. The example here is Unilever. They have roughly 1,000 websites, out of which they have already migrated around 500 to AWS. Using AWS, Unilever can now deploy websites in 2 days in production instead of 2 weeks in the past. Or Bristol Myers Squibb, who migrated its clinical trial simulation platform to AWS. Now their simulations take 72 minutes compared to 60 hours earlier. So they went from 60 hours to 72 minutes. The final strategy, number 6, is all in, transitioning yourself to a cloud-native company. And one of the shining stars here, who are often quoted, is Netflix. A few years ago, Netflix decided to move all of their applications to the cloud and become a cloud-native company so that they can fully leverage the benefits of cloud. Now we are seeing more and more companies companies make this decision. Okay, wrapping up. What are the next steps? What are the takeaways? If you haven't done so already, please go to aws.amazon.com and sign up for an account. And definitely take advantage of the free tier. Using the free tier, you can try many of the services at AWS without any cost. It's a really nice way of experiencing it yourself, hands-on, and getting a better understanding how things really work in the cloud. And then start experimenting, start innovating, and start building those next generation great applications. Thank you very much. My name is Markku Lepistö. I'm a technology evangelist at Amazon Web Services, working out of sunny and beautiful Singapore. Now, we have 10 minutes left. I think we are right on time. It seems that our super efficient guru SAs have already answered most of the questions. So let's spend here one more minute to see if anybody has any new questions. Our SAs are too fast. There is a question coming in. Does AWS have separate interfaces for service providers, enterprise IT, and end users? Yeah, that is a complicated question. So basically, yes and no. So first of all of the interfaces, all of the ways that you can interact with AWS are the same for everybody. We call this sitting on the shoulders of giants. So even the smallest startups can leverage all the same services and all the features of AWS as the very large enterprises that use it already today. When it comes to interacting with AWS, we have the web console, where you can log in and interface with the cloud using the web. We have the command line, and we have finally the APIs. Leveraging the APIs, you can programmatically access AWS services. You can programmatically provision, for example, EC2 virtual machines, databases, directly from your application code. Your question was about service providers and end users. This is the same for everybody, bundled also with identity and access management, so access control, authorization, granular security settings, etc. The idea here is that if you are a service provider who wants to leverage AWS services, my recommendation is that you will templatize your offers maybe with CloudFormation. You will build your own management systems maybe, or leverage third-party tools that use the APIs to interact with AWS. So if you want to provide a service that is leveraging some of the services of AWS, you will definitely want to automate this, to have operational efficiency. Automate everything. And the best way to automate everything is either using API calls or templates. More questions? Is AWS deployment 100% cloud, or, hang on a second, is AWS deployment 100% cloud or hybrid for service provider? That depends on the management tools. AWS absolutely supports hybrid deployments where you have some on-premises systems and then you may have an AWS account or more. Basically, what you need are tools that can talk to both systems. Tools with which you can manage your applications and services either in your on-premises systems or in AWS. Some tools available in the market, some third-party tools, provide single pane of glass management with application lifecycle management, where you can deploy the application either in your on-premise system or in the cloud. Or maybe manage hybrid applications where a part of the application is running in the cloud, let's say the big data analytics, and some of it is running on-premises, like the Samsung financial services. And you can achieve this by having secure connectivity between your office or your data center and the AWS cloud. Using, for example, our VPC, you can have VPN tunnels, IPsec VPN tunnels over the internet, or even the AWS Direct Connect, where you have your own dedicated cables to peering points that go to the cloud. So the idea is that with Amazon VPC, you can extend your existing IP networks and subnets into the cloud. This way, it's easier for your management system to actually manage the resources, whether they are in the cloud or in your on-premise system. Our army of essays here has been extremely efficient, so I think unless we have more questions, I will still give it a few seconds. We may move forward and start wrapping up. There's one more, but the essays are already on it. So let's move on. So, everybody, first of all, big thanks for joining. But before you sign off, your feedback is extremely important to us. AWS is a customer-obsessed company. We want to continuously iterate and improve our services and the way we interact and the offerings we provide to you, such as these webinars. So please complete the survey. Please let us know what was good about it, what wasn't so good, what you want to see next, maybe, what you think we are missing, what you want AWS to deliver to you.